Welcome to Ask Electrical. Today we are going to discuss about the components of DC machine, materials used for making them and their function in the machine. The components of DC machine are as follows. First is the yoke or magnetic frame. It is the outer covering of the machine which has the following function. First, it acts as protective cover for whole machine. Second, it provides mechanical support for the poles. Third, it carries magnetic flux produced by the poles. In small machines, cheapness is the main consideration. Hence, yokes are made up of cast iron. But for large machines, as weight is the main consideration, hence yokes are made up of cast steel. Second one is the pole core and pole shoe. Field magnet consists of pole core and pole shoe. First, pole shoe. It is generally has larger cross section which helps spread out flux in air gap and reduce reluctance of the magnetic path. Secondly, they support exciting coils. Pole shoe are made up of laminations of cast iron or cast steel and fastened to pole core by countersunk screws. Second one is the pole core. It is a solid piece made up of cast iron or cast steel. However, in modern design, the complete pole core and pole shoe is made up of thin laminations of annealed steel and riveted together under hydraulic pressure. Lamination thickness varies from 1 mm to 0.5 mm. The function of pole core is to hold the exciting coils or winding through which current flows. Third is the pole coil. It is nothing but field winding made up of copper wire or copper strip. It is firstly wound on farmer of correct dimension, then farmer is removed and wound coil is placed on the pole core. When current passes through these coils, they electromagnetize the poles which produce flux. Now fourth component is the armature core. It has slots on outer periphery to hold armature conductor. Mounted on the shaft, armature core helps armature conductor to rotate and cut the flux. The most important function is that it provides low reluctance to the flux to pass from north pole, then through armature winding and armature core and back to the south pole. It is cylindrical or drum shaped and built of circular steel laminations approximately 0.5 mm thick. It is keyed to shaft. It also has circular ducts to permit axial flow of air through armature for cooling purpose. Now fifth is the armature winding. The armature windings are usually former wound. The conductors are placed in the armature slot which are lined with tough insulating material. When machine acts as motor, the armature carry current, whereas it supply current out of the machine when it acts as generator. Next comes the commutator. A commutator is a cylindrical structure built of wedge-shaped segments of hard-drawn copper which are insulated from each other by thin layers of mica. The number of segments is equal to the number of armature coils. Each segment is connected to armature conductor by means of copper lug or strip. Commutator plays an important role during motoring as well as in generating action. During motoring, it maintains the unidirectional flow of current through the conductor to maintain the torque in same direction, thus helping motoring action to take place. While during generating action, it rectifies and converts the AC sinusoidal current generated into pulsating DC. Next comes the brushes. Brushes are made up of carbon or graphite and are in the shape of rectangular blocks. Commutator segment slides on brushes. Placed on commutator, the function of brushes is to collect current from the commutator when machine act as generator, whereas when machine act as motor, it supply current to the commutator. Next part is the shaft. It is placed in the bearings. Armature assembly is placed on it. Shaft helps the armature to rotate in the magnetic field and cut the flux. The material used for making shaft is mild steel or rolled steel. Next important part is the bearings. Bearings are placed at the center of end plates of the machine casing. In bearings, shaft is placed. For light duty machines, ball bearings are used, whereas for heavy duty machines, roller bearings are employed. Bearings help to have smooth rotation of shaft. It helps to reduce the wear and tear of the shaft. Next part is the terminal box, usually mounted on the top of machine yoke. It is made up of cast iron. All the armature connections are taken and brought out in the terminal box. It provides feasibility for user to collect or provide power to the machine. So this was all about today. Hope that you understand the video. We will meet in the next video. If you haven't yet subscribed my channel, subscribe now and press bell icon for latest updates. Also do like and share if you like the video. Thanks for watching.